Good day. My name is Javier and I'm from Mapua Institute of Technology. This video is about the balancing beam. My group mates are Zylene Timajo, Elxis Estanislao, Kevin Mendoza, and Javal. Throughout the video, my group will discuss about the materials used in implementing the project, how the machine works or the operation of the project, the calculations we have derived in relation to strength of materials, and the project's real-life application. For the materials used, it will be discussed by Zylene Timajo. For the operation or how the machine works, it will be discussed by Elxis Estanislao. For the calculations, it will be discussed by Kevin Mendoza. And for the real-life application, it will be discussed by Javal. So for the discussion of the materials, here is Zylene Timajo.
The materials used in the projects are the acrylic board, bow screw, the servo motor, the ultrasonic sensor, and the Arduino.
To explain how the system works. So basically, our system or balancing beam has three main components. First, the ultrasonic sonar sensor. Second is the servo motor. And lastly, this Arduino. So this is how our system works. So first, we have this ultrasonic sensor which measures the distance of the object from in the beam so that it will know its position. That is important because our system works based on distance. It will measure how much the object is displaced from equilibrium. So to be able to balance this beam, we have a servo motor here which will exert an upward force to the beam so that the beam can go up or down until the object is placed on its equilibrium. So everything is possible through this Arduino because it serves as the brain of the systems. It does all the computation based on the distance and the force that will exert by the servo motor.
I'm Maridella Javal from the School of EECE. This is the free diagram of the balancing beam. As you can see, there's a distributed force going downward due to the weight of the beam, a force going downward due to the weight of the sensor, another force going downward due to the weight of the object being balanced, and it will eventually vary. A force exerted by the support connected to the servo motor. It will vary because of the changes in the servo motor's angle. Another force exerted by the support connected to the beam and the stand, and it is not varying. This represents the load diagram of the project. This represents the ball in a distance of x. This represents the support connected to the servo motor, which represented by the distance of y. This serves as the support, which connects the beam and the stand. And the full length of the beam is 12 inches. And this represents the servo motor. The parameters which are variable are the position of the ball, or the object, the position of the servo motor, and the parameters which are constant is the weight of the ball, weight of the beam, weight of the sensor, weight of the support of the servo, and weight of the acrylic. Here is the computation for the maximum stress, positive and negative, maximum moment, positive and negative. This represents the shear and moment diagram of our project. There were distributed forces in here due to the weight of the beam, so it causes the line goes downward. And then, at this point, it goes downward because of the weight of the object. At this point, it goes upward because of the force exerted by the support connected to the servo motor. At this point, it goes upward again because of the force exerted by the support connected to the beam and the stand. And then, it goes downward because of the weight of the sensor. And moment diagram, the area of this, the area of this, the area of this, and this area. So, this is how the shear and moment diagram are made. And you can also change the ball's position. Example 5. And as you can see, the shear and moment diagram changes. Also sa servo motor, position 2, 5. Here, it changes. So, thank you.
Hello, my name is Kevin Mendoza and I'm doing a report for strength of materials under Engineer Pilones. First of all, the beam has a uniformly distributed load, which is its weight. The distance x is the variable distance of the ball from the side. The distance y is the variable distance of the support of the servo. In finding F servo, we need to take the moment at F post. We also need to realize how the uniformly distributed load has two components, one in the clockwise direction and the other in the counterclockwise direction for the moment. To solve for F post, we just need to take the summation of vertical forces. The next thing we need to look at is the shear and moment diagram. As we can see, the uniform load causes these inclines, while the concentrated load produces the sharp decreases and increases in the shear diagram. The moment diagram is just the integral of the shear diagram, as we can see from first order up to second order. The next part is about taking the maximum horizontal stress and maximum bending moment. To solve for either, we need to find the moment of inertia of the figure. And before that, we need to find the centroid of the whole figure. Okay, the formula for horizontal shear stress is F max, QV over IB. Remember that B is the thickness where we solve for the static moment of inertia Q. In this case, we use the upper half since it only has two components versus the three components in the lower half. V is taken from the shear stress diagram, which in this case is supposed to be the maximum shear stress experienced. For bending moment, we use the formula Vmax is equal to mc over I. Remember that C is the maximum vertical distance from the centroid. So again, this is the distance from the top half to the centroid. And M is taken from the moment diagram. That is all. Thank you.
For the application of our project. Our project has a concept wherein there's a reference, and that reference may be of a distance, angles, or other parameters. And the object or thing should be on that reference so that it can be stable whenever that object changes or varies. Other parameters also changes based on the system or the user itself so that it will become stable again. Like for example in buildings. Example, this is the base of the building, and whenever there are natural calamities or other situation wherein it will change its angle or it will shift from left to right. On that system, on that control system, there's this counterweight wherein it will make the other side of the building goes down and it will become stable again. Another example is for the speedboats. When speedboats, because of the waves, it tilted from left to right. And for it not to fall off of the river, they needed to have a reference. wherein it will be stable. And for that to happen, they need the concept of being stabilized like our project. So there are a lot of different applications wherein stability or being on the reference should be really needed, like for the dams. So other application may include chemistry or mechanical system and electricity and other stuff for it to be matters. So that's all.